Hi, I'm Mr. Kangas, and today we're going to take a look at Chapter 12, Section 9, Permutations and Combinations. And in this video, we're going to be taking a look at permutations in particular. What I have up here on the board is a way you'll commonly see permutations listed. You're going to see a P, and then in parentheses, you'll have what looks like an ordered pair. And what that ordered pair is telling you is that you have 5 things being taken 2 at a time. So in other words, let's say we're talking about 5 students running for 2 offices in student council. So let's say they're running for president and vice president. Okay, only 2 of these 5 students is going to be vice president, and what we're going to be doing is we're going to be trying to find out how many permutations of we can come up with, or in other words, how many different ways can we represent these 5 students in those 2 offices. And the reason why it says that it's an arrangement or listing in which order is important is because let's say John got president, and let's say Sally got vice. Okay. If John gets president and Sally gets vice, that is not the same as Sally getting president and John getting vice. Those count as 2 different permutations because those are 2 different things. In one case, Sally's president. In the other case, she's something totally different. So order does matter. So whoever you choose for president is going to affect who you can choose for vice president, but more importantly, that person when he's president compared to when he's vice president, those are 2 different things. An example where order wouldn't matter is if, for example, you were choosing colors for your school flag. Now, if you had 3 colors to choose from, let's say you had red, green, and blue to choose from, and you had to vote on 2 colors that you wanted your school flag to be, if you chose green and then blue, that would be the same thing as if you chose blue and then green. Regardless, you're going to have blue and green in your school flag. The order in that case doesn't affect anything. Whereas the order in this case, where we're talking about student council, the first pick is going to land you the president slot, but if you're second pick, then you're going to get the vice president slot. So that does change things. It changes what position you can hold. Whereas choosing the colors for your school flag doesn't matter if you choose green first or blue first. Either way, you're going to have a green and blue flag. So that's what they mean by order matters. Somehow the order is going to affect either what order you're batting in, what position you're holding, something along those lines. So another example of a permutation would be batting order in a baseball or softball game. Whether or not you're batting first, second, third, or fourth, in a lot of ways dictates your role as a batter on the team, because a lot of times the third and fourth batter are considered the cleanup hitter. The first batter is typically your person who you're trying to get on base. They usually have the best batting average, and they're great at getting base hits. Things like that. So how do you figure out all the different permutations? Is pretty simple. Basically, we have 5 things, and there's 2 options to split them up amongst. So we're taking 5 things, 2 at a time. So the first pick is going to be for president. Whoever gets picked first is president, and there's going to be 5 options for president. And you're going to multiply that by however many options there are for vice president. Well, after the president's been chosen, there's only going to be 4 options left. There's only going to be 4 kids left who have not filled a position. So you're going to have vice presidents basically going to be an election amongst 4 people, whereas the president, you had 5 people competing. And so, just like in the previous chapter, when we're counting outcomes, you're going to do 5 times 4, and you're going to get a total of 20 different permutations. So there are 20 different possible outcomes for president and vice president combinations. Let's say we changed it up, and let's say we are doing an election, and instead of just doing president and vice president, we're also adding in secretary and treasurer. Well, at that point, we would be taking 5 students 4 at a time, and so we would do 5 times 4 times 3 times 2. First choice is president, vice president, treasurer, and then secretary. And as you choose one, every time you choose the president, that means vice president only has 4 people competing. After you choose vice president, there are only 3 people competing. And after you choose the treasurer, there are only 2 people competing. And so in this case, if you want to see how many different combinations you could have, you would have to do 5 times 4, which is 20, times 3, which is 60, times 2, which is 120. So there's a total of 120 different possible outcomes or permutations in this instance. In order, again, it does matter. Depending on when you are picked, depends on what position you get to hold on student council, if you even get to hold one at all. So that is permutations. Again, you're looking for problems where order does matter, where order makes a difference in the end. What position you're picked, or what position or time that something is picked will change the outcome in some way. Remember, the key example I gave where order didn't matter was the school flag. Okay, if you had a choice, you could pick any 2 colors you wanted. It doesn't matter if your first pick was blue and your second pick was green. Both those colors are going on the flag, so if green is first or blue is first, doesn't matter. Green and blue will still be your school colors. So that's all I've got for you on permutations. If you have any questions, please pause it, let me know. Make sure you took notes on this video. And in the next video, we're going to be talking about what are known as combinations. And those are actually when order doesn't matter, and we're going to talk about those next. So those are basically the permutations when order doesn't matter. That changes the number of outcomes that you can have. It actually pretty significantly reduces the number of outcomes that you can get. Because, for example, you would, with the flag in a combination, if you chose green and then blue, that would count as one combination. And at that point, once you chose green and blue, blue and then green would not count as a combination because they're essentially the same thing. But we'll talk more about that in the next video and how to solve for combinations. So.